Hello everyone. I, Dr. Vinod Kushwaha, Assistant Professor, Department of Physics, Hindustan College of Science and Technology, Farematara. Today, I am going to deliver acceptance angle of optical fiber. What is acceptance angle? It is defined as maximum angle that light can have travel relative to axis of fiber and propagate down the fiber. This is called acceptance angle. It is represented by theta maximum. So theta maximum is the permission of light ray. So I calculate acceptance angle mathematically. Now if any optical light ray induced in the fiber at an angle to the axis of fiber, if refracted ray made an angle, this one is incident angle, theta naught is in the air, so theta naught equal to theta I, incident angle, and strike on the core surface, so the light has been refracted, the angle made theta R with exit and striking core cladding interface at an angle phi. This point is V. So theta I is the incident angle, theta R is the refractive angle of core, and phi is greater than phi C, critical angle. So this is the condition of TIR. Phi is greater than phi C, then signal move to zigzag form. So apply the Snell's law and calculate the theorem. Now for the principle of TIR, phi is greater than phi C. So phi is greater than phi C. Now according to Snell's law, this one is air medium and this one is core medium. So according to Snell's law, N naught is the refractive index of air medium. N naught sin theta I equal to N1 is the refractive index of core. N1 sin theta R. This is the Snell's law. So sin theta I upon sin theta R equal to N1 upon N0. This one is equation number first. So now the largest value of theta I when phi equal to phi C, the signal propagate on the straight line. Now the largest value of theta I occurred when phi equal to phi C. So in triangle A, B and C, sin theta R equal to sin 90 minus phi. In triangle ABC, sin theta R equal to sin 90 minus phi. Sin 90 minus phi equal to cos phi. So this is equation number 2. Now by equation first, sin theta I upon sin theta R, we apply this condition. Sin theta I equal to N1 upon N0 cos phi. So maximum angle phi equal to phi C. So cos phi C. By equation first, sin theta I equal to N1 upon N0 cos phi C. This is equation number 3. When phi equal to phi C, When phi equal to phi c, then theta I equal to theta maximum. So sin theta maximum equal to n1 upon n0 cos phi c. This is equation number 4. Now we move to point B. At sin phi c, sin phi equal to phi c, this one, phi equal to phi c. Sin phi c perpendicular upon hypotenuse. So perpendicular is AC and hypotenuse is AB. So sin phi c at point B, sin phi c equal to n2 upon n1. Then this is the right angle triangle. So sin phi c upon sin 90 degree equal to n2 upon n1. We know that the condition of sin square phi c plus cos square phi c equal to 1. So we know the condition, we know that sin square phi c plus cos square phi c equal to 1. Then cos square phi c equal to 1 minus sin square phi c. What is the value of sin square phi c? n2 upon n1. The value put in this equation. So cos square phi c equal to 1 minus n2 upon n1 whole square. Solve this equation, cos square phi c. Now cos phi c under root 1 minus n2 square upon n1 square. Solve this equation. Cos phi c equal to n1 square minus n2 square upon n1 square, the value of cos phi c. So this value put in above equation. What is the value of cos phi c? Cos phi c put in equation number 3. So sin theta maximum equal to n1 upon n0 into cos phi c. The value of cos phi c put in this equation. So the value is n1 upon n0 under root n1 square minus n2 square upon n1 square. We are taking the under root. N1. This terms has been cancelled out. So the equation is n1 square minus n2 square upon n0. For the condition of air, the refractive index of air for air medium, n0 equal to 1, then sin theta maximum equal to n1 square minus n2 square. So theta maximum equal to sin inverse under root n1 square minus n2 square. This is acceptance angle. So I hope you understand this mechanism and derive the equation of sin theta maximum. Thank you so much. Now the next point in optical fiber is acceptance cone. What is acceptance cone? Light ray contained within cone having full angle. Full angle means when the light travel in the core medium, this is the cross section area, light hand will enter in this path theta naught. Light is free to move any direction. This is also theta naught. So the complete angle is 2 theta naught. This is cone shape. So this is acceptance cone. This is core. So light ray contained within cone having full angle 2 theta naught are accepted and travel along the fiber. This phenomena is called acceptance cone. So cone equal to 2 theta naught. Theta naught is the acceptance angle. So 2 into angle. Now next feature is relative refractive index difference. Relative refractive index difference. It is the ratio. It is defined as the difference whereas refractive index of core and cladding to the refractive index of core. This is the difference between refractive index of core and cladding to the refractive index of core. It is defined by delta. So delta is n1 minus n2 upon n1. If we calculate the value of delta, n1 is always greater than n2 for total internal reflection. So this is called relative refractive index difference. So relative refractive index difference, delta equal to n1 minus n2 upon n1. So it is defined as the ratio of difference between refractive index of core and cladding to refractive index of core, which is represented by delta. So delta is always positive. Remember it, delta is always positive due to total internal reflection because n1 is always greater than n2. So this is relative refractive index difference. Now next point is numerical aperture, which is defined by Na. So what is numerical aperture? It's defined as sine of acceptance angle. This is measured by the amount of light accepted by fiber. So Na equal to sine of acceptance, sine theta naught, a theta maximum. What is the sine theta naught? Na equal to under root n1 square minus n2 square. This is equation number 1. So factorial has been generated. N1 square minus n2 square, n1 minus n2 and n1 plus n2. We apply the one mechanism. So generate the value of Na divided by n1 multiplied by n1 and divided by 2 multiplied by 2. Why we are choosing this type of mechanism? Because n1 minus n2 upon n1 is relative refractive index difference. So this is called delta. and N1 plus N2 by 2, this is the average value of N1 plus N2. So what is the value of N1 plus N2? Because core value is always greater than cladding value. So the value is nearby core value. So the value is come N1 and N1 into 2. So the total value is 2 N1 square delta. If we take Na, now Na equal to N1 under root 2 delta. This is the calculated formula when we calculate the numerical aperture of an optical fiber. Now the special type of parameter which is known as cutoff frequency. What is cutoff frequency? An optical fiber is characterized by an important parameter known as V number. V number is normalized frequency. What is the formula of V number? We calculate the value of V equal to 2 pi A upon lambda under root N1 square minus N2 square. N1 square minus N2 square equal to Na. So V equal to 2 pi A upon lambda into Na. V is the cutoff frequency, A is the radius of core, A is radius of core and lambda is the wavelength of light. N1 is refractive index of core and N2 is refractive index of cladding. So V equal to 2 pi A upon lambda into Na. What is the value of Na? 2 pi A upon lambda N1 under root 2 times into delta. This is the calculating formula of V number. The maximum number of modes propagating by fiber is defined by N maximum. N maximum number of mode equal to V square by 2. For a single mode fiber, V is greater than 2.405. For multimode fiber, V is lesser than 2.405. Multimode fiber, V is lesser than 2.405. So the approximate wavelength, the value of V equal to 2.405 is known as cutoff wavelength. So V equal to 2.405 is cutoff wavelength. Then equation is lambda C. Lambda C is the cutoff wavelength. Lambda V upon 2.405. This is cutoff wavelength. Now the value of graded index fiber N maximum equal to, for green, N maximum equal to B square by 4. So this is the formula of calculating the cutoff frequency. I hope you understand this mechanism and prepare the optical fiber cable. Thank you so much.